In this video, we look at solving single-step equations. So solving an equation means to find the value of the variable that makes the left and the right sides of the equation equal. If we look at the example down here, x plus 4 equals 2, we're trying to find out what x has to be to make the left side of the equation equal to 2. We're going to go through this using what we call a double number line. So I'll walk you through how that works. I'm going to start out by putting x plus 4 on a number line. So here's my number line, and here's x plus 4. We know that x plus 4 has to equal 2, so I'm going to use the second number line right below the first one. And this this red line here is going to show that x plus 4 and 2 are the same. We want to figure out what x is. In order to find out what x is, we're going to look here and say, well, if this is x plus 4, where does x have to be? Does it need to be to the left or to the right of this point right here? Remember that x plus 4 means that this number is 4 bigger than x. That means that x needs to be to the left 4 spots. 1, 2, 3, and 4. So there's x. We want to figure out what x equals, so we're going to do the same thing on the bottom. We're going to move by the same amount down here. So we moved 4 to the left from 2 all the way to -2. And again, we can show that those two values are the same. So x has to equal -2. If we look at this algebraically, it looks kind of like this. Here's the question that we started with. Remember that we subtracted 4 from the x plus 4. So here's subtracting 4 from x plus 4. And we did the same thing to the 2. When we talk about equations, we often talk about doing the same thing to both sides of the equation to make sure that they stay equal. On the left side of the equation, we have x plus 4 minus 4. Well, plus 4 minus 4 is 0. And on the right, we have 2 minus 4. So if we simplify this, we get the solution to the equation. X is equal to -2. If we want to, we can check to make sure that our answer is correct. We can substitute our answer of -2 back into the original equation for x and make sure that the left side and the right side are still equal. -2 plus 4 equals 2, so we do in fact have that the left side and the right side are equal. Let's have a look at another example. Let's look at this one right here. 2x equals 14. So again, we're going to do the same thing. We're going to put our number on a number line. Here's the number line. Here's 2x. And we need a second number line right here. And we're saying that 2x is equal to 14. So 2x and 14 are lined up. We want to figure out what x is. So we need to figure out, where does x go on the number line? Well, if 2x is here, where does x have to be? Well, somewhere in between, like halfway in between 0 and 2x would be x. That's right here. How do we get from 2x to x? Well, we just have to divide by 2. And whatever we do on the top side, we're also going to do on the bottom side. So we're going to divide by 2. 14 divided by 2 is 7. So we get that x is equal to 7. Again, the x and the 7 lining up. We can look at this again algebraically. We started with 2x equals 14. We then divided the 2x by 2, and we divided the 14 by 2. 2 divided by 2 is 1, leaving us with an x on the left side of the equation. 14 divided by 2 is 7, so we get that x equals 7. Again, we can check by substituting into the equation and making sure that the left side and the right side are equal. Let's look at a third example. This one involving some subtraction. So x minus 3 equals -7. So again, we're going to start with a number line. Here's our number line. Here's x minus 3. And here's -7. Now this time, we can actually look at this as two number lines, or we can just look at it as one. You may want to compact your number line. I'm going to keep 2 just to keep things nice and simple here and not get too cluttered along the number line. So again, we're saying that x minus 3 equals -7. If this is x minus 3, where must x be? Well, this is 3 less than x, so x must be to the right 3, and we get there by adding 3. We're going to do the same thing on the bottom number line. Add 3, and we get to negative 4. So again, we'll look at this algebraically. Here's the question. X minus 3 equals negative 7. We added 3 to both sides, and we ended up with a negative 4. So here's the adding of 3, which is what we did over here. Negative 3 plus 3 is nothing, or 0, leaving us with x on the left. And negative 7 plus 3 is negative 4. So the double number line strategy is a great strategy for visualizing what's going on. All right, let's have a look at one final example here. The example that we'll look at now is x divided by 2 is equal to 5. So again, pull out the number line. There's our x divided by 2. We know that it's equal to 5. So here's our second number line lined up at 5. So there's x divided by 2 equals 5. If this is half of x, which is what x divided by 2 means, think about what that means for x. X needs to be bigger, and in fact, it needs to be twice as big. So we do the same thing here on the bottom. We start at 5. We want to be twice as big as x. So we can multiply that by 2, and we get that x has to be 10. Algebraically, same sort of thing. We started with x over 2 equals 5. We multiplied both sides by 2, or in this case, the top and the bottom by 2. 2 divided by 2 is 1, so we're left with an x on the left. And 5 times 2 is 10. We get x equals 10. So the way that we solve one-step equations is just by performing inverse operations. We saw here a double number line worked really well. At some point, you might be ready to move on beyond the number line, in which case you can just think about inverse operations. So the inverse operation to dividing here was multiplying. We were dividing by 2. Inverse operation is multiplying by 2. We want to undo whatever operations being done to x, and we do that with the inverse. Up here, we were subtracting 3 from x, so the inverse of subtracting was adding. Thanks for watching.